Good evening, Prof. Chen and my dear fellows. We are Group Zero Risk, and our presentation is the forecasting of unemployment rate and stock price. First, I will introduce our general idea, then my teammates will go through each model and discuss the results. Different modeling approaches were chosen through our analysis. As there are many other factors may influence the unemployment rate, we choose ARIMA and ARIMA X models. In contrast, for the stock price, we choose VAR as there exists correlation between countries. The first part is using a ARIMA model to predict unemployment rate. The graph shows that the curve turns to stationary when D equals to 2, and the subsequent KPSS tests also verify our suspicions.
Next, the ACF and PSF plot shows that we can choose a ARIMA model with P equals 1 or 8 and Q equals 1. And based on AIC and MAPE, we choose ARIMA 0 to 1. The residual analysis also shows that this is an appropriate model and there is no sign of scarcity effect. And finally, we'll predict the unemployment rate in Singapore for the following months. Likewise, for the US, after observing and doing KPSS tests, we choose parameter D equals 1. Next, based on ACF and PSF plots, we choose P and Q equals 0 or 1. And based on AIC and MAPE, we chose ARIMA 010. The residual analysis also shows that ARIMA 010 is an appropriate model. So like before, we also predict the US unemployment rate for the following months.
For better forecasting, we also use the ARIMA X model. ARIMA X is related to the ARIMA technique, but while ARIMA is suitable for datasets that are univariate, ARIMA X is suitable for analysis where there are additional explanatory variables. The unemployment data is suitable for the ARIMA X because there is more than one variable correlated to the unemployment rate, such as CPI, interest rate. First, we plot the correlogram. It shows that unemployment data are positively correlated with CPI and interest rate. We also plot the cross correlation that tracks the movement of unemployment data relative to other data. Based on the above result, we choose CPI, interest rate as explanatory variables. Next, we choose the most suitable ARIMA X model based on AIC and MAPE. Finally, we can get the prediction of unemployment based on the model we choose above.
Next, I will talk about stock index price forecasting. For our stock market index model, we choose to use daily log returns of the 3 countries. As part of our data preprocessing, we eliminate those days where one or more markets are closed. For example, August 9th, on which Singapore market is closed for holiday. We consider VAR model because we find that these time series are highly correlated, and based on Ken and Ken's paper, VAR model will likely generate greater performance than the RIMA. We then plot MTS and CCM. The graph suggests that there are serial order correlations, so simplified VAR model seems suitable for the dataset. After we have run VAR order and calculated MAPE, we decide to use VAR2 due to its lowest BIC, relatively low MAPE for validation period, and smallest order among 3 orders. Eventually, our model results in a MAPE of 0.98 for test period. The high MAPE is probably caused by our daily frequency of data points and the low signal-to-noise ratio of financial data. Given a fixed time horizon, steps increase as frequency increases. As demonstrated in the graph, log returns tend to 0 as steps increase. On the other hand, however, all real values fall in the forecasted range for STI and UKX, and 97.44% fall in the forecasted range for SPX. We thus propose the following model and conclude that the US dominates the global market. And next, I'll hand over to Li Xin to introduce another attempt on a deep learning model.
Since results so far are not really ideal, we try some deep series network to model this time series. Traditional series network includes recurrent neural network like long short-term memory or gated rated unit. Almost all of the recent network includes a transformer framework whose core is attention mechanism, just attention is all you need. We model the SP500 and STI by converting them into return rate and set the window width as 250, because in 1 year, there are about 215-year trading days based on our daily stock data. Unfortunately, our deep network without other features cannot predict over the long term as well, although the MAPEs on test set are much smaller than VAR. So where's the problem? Just think that we just model the past time without other features or factors, even if our hidden layers are deeper and deeper. It didn't work, it seems insufficient. Maybe modeling the series combining deep network and more features will help. The factors may be more important than the models. And that's the end of our presentation. Thank you.